Now let's talk about temporal frequency and spatial frequency. So let's start with temporal frequency. So temporal frequency is calculated using the Greek variable omega. So omega is equal to 2 pi over p, or 2 pi over the period. So omega, also called angular frequency, tells you how much cycles you are in per one whole cycle, per one period of a cycle. Sorry. So let's have here a graph of time and cycle. So when time equals the period t, so for example we have 5 seconds, so the period of a wave is 5 seconds. This means that it takes 5 seconds to move from here to here. This means that the number of cycles that this wave has completed is already 2 pi. So if we take half of the period here, let's say 2.5 seconds, it will be 1 pi. If we start from 0 seconds, the wave hasn't even completed one cycle yet, so 0 pi. So if we trace this graph, it will become a line. So what this angular frequency tells us is simply the slope of this line. So it tells you how much cycles you have per one unit of period. So next we will talk about spatial frequency. So spatial frequency is calculated using the variable k, which is the wave number. So the wave number is equal to one full cycle 2 pi over lambda. So let's have a graph here of position versus cycle. So when we have one whole wavelength, so this is one whole wavelength here. So let's say that one whole wavelength of this wave is 1 meter. This corresponds to one whole cycle on this wave. So this will be 2 pi, and similarly to what we did with the the temporal frequency, this will be 1 pi, this will be 0 pi for 0 meters. So again, if we trace this line, it should take a straight line, and the slope of this line should be the wave number. So it's just the ratio of one whole cycle 2 pi over the period of the wave. So that is temporal frequency and spatial frequency. So temporal frequency is just how steep the slope of the cycles and time, while spatial frequency is how steep the slope of cycles versus spatial value of x. So next, we also define a quantity called frequency. So this is different from what we have defined as spatial frequency and temporal frequency. So frequency is came from this equation, omega equals 2 pi f. So f equals 2 pi over omega. So frequency tells you the number of cycles per unit of time or per second. So it is measured in hertz. Or if you want to take the units of frequency, it is equal to 1 over second or cycles per second. So lastly, we define the speed of any periodic wave. So the wave speed is just simply equal to the temporal frequency over the wave number. So recall that temporal frequency is 2 pi over t, and this wave number is 2 pi over lambda. So you can also write this as 2 pi cancels out, lambda over t, or since t is equal to 1 over f, this becomes v equals lambda f. So these are two ways to calculate wave speed using temporal and spatial frequencies, or lambda and just frequency.